like to talk about some derivatives, okay? Derivatives of exponential functions. So the basic rules are these two. E to the x is its own derivative. Any other base will differentiate as the original exponential expression times the natural log of the base. Now, if a was to this rule does work. This rule does work for a equals e. Okay, but e to the x would differentiate under this rule as e to the x times the natural log of e. Natural log of e is 1. So e to the x times 1 would give me e to the x. Okay, so that's the reason why these two rules are explained differently. Okay, so example 1. We're looking for our derivatives. So f prime of x is, well, 93.2, and the derivative of e to the x is e to the x. Okay? Now, example 2, I have f of x equals 93.2 to the x power itself. This is the rule that I would follow for that situation. So that's going to be f prime of x equals 93.2 to the x times the natural log of the base. And that's it. Okay? So, example 3. F of x equals e to the x to the 11th plus 25. F prime of x would equal e to the x to the 11th plus 25 times the derivative of the exponent. So that'd be 11 x to the 10th. Okay, so f prime of x would ultimately equal 11 x to the 10th times e, and then the original exponent would stay as is. Okay, that's a pattern that I'm hoping everybody will quickly recognize, is that the original exponential expressions always stay. Other things get tacked on, but the exponent might get tacked on, but the exponential expressions always stay. So for instance, example 4. Okay, 1,000 to the x cubed minus 15th power. F of x. So example 4. F of x equals 1,000 times x cubed minus 15. Well, that's going to be f prime of x equals, you're going to have the original exponential expression and then you're going to have the natural log of your base, so natural log of 1,000 times the derivative of whatever this was. So that'd be 3x squared. So, f prime of x could be written as 3x squared times 1,000 x to the third minus 15 as an exponent. I'll move it down for clarity's purposes. So f prime of x would equal, I'll put that in the front, and then I'll put that in the middle, and I'll end it with the logarithm of my base. Natural log of 1,000. Okay. You'd like to review that, hit your pause button. Otherwise, I'm going to erase the board and move on. Example 5. F of x equals (40) e to the x to the 5th minus 9. F prime of x will equal 40 times e x to the 5th minus 9 times the derivative. So that would be 5x to the 4th. So f prime of x will equal 200 x to the 4th e x to the 5th minus 9. Here's another one. Here's another one. Example 6. F of x equals 900 e to the point 0.6 x power. F prime of x would equal 900 times 0.06 e to the 0.06. Well, let me do it the other way, okay? Well, I'll do it a different way. So I'll follow the chain rule way first. So I'll be 900 times e to the 0.06 x power times the derivative of your exponent times 0.06. Okay? That would give me 0.06 times 900 is 54. And that's going to be e to the 0.06 x power. Okay? Okay. So I have a couple more. I'm going to do them one at a time. So this one right here is going to follow this rule right here because the base is e. So f prime of x will equal 15 and your original exponential expression. Times the derivative of the exponent. So that's going to be 9x to the 8th minus 2x plus 13. Now, I'm going to rearrange this so that the exponential expression is last, and I'm also going to leave it factored. So I'll have f prime of x equals 15 times this and then the exponential expression goes last. Like so. Okay? Now example 8 is going to follow this rule right here. Okay? So f prime of x will equal the original exponential expression, 111 times 83 to the x minus 47 times the natural log of the base, 111. Okay? Times the derivative of the exponent. So that would be, the derivative of this is just 83. Okay, so f prime of x is generally what they're going to, what some people do is they'll put the regular number first, the derivative of the exponent first, then they'll put the original exponential expression in the middle. This is the way I normally write it, to be honest. And then times 10 times the natural log of your base. Okay? That is normally how I write it. Okay? But as long as everything is there, it's accurate. Yeah, I'm going to make this the same size as everything else. Okay? So as long as you have the original exponential expression, so the natural log of your base, and the derivative of your exponent, it's accurate. All right? And I am going to stop. Okay, here I'm going to discuss a other type of interest, okay? Compound interest. Compound interest has two subtypes, continuous and periodic. Now, some courses include periodic only, okay? College algebra classes, business math class, advanced business math classes, applied calculus classes, which is also business, usually business calculus, usually include both of them as well. I think it's easier to start with continuous, so that's what I'm going to do first. Okay? So, but I will at least give people an idea of what this looks like for later. Okay? So, accumulated value equals the principal, and then this is where things change, become different between the two of them. E is a constant. It's 2.71. It's approximately 2.718281828 and then it goes all over the place forever. Okay. You'll hit shift or second. You'll hit shift or second ln on your calculator to get to that feature. Okay. For periodic, it's 1 plus the raised decimal, and this is still time. This is what causes the most confusion because it's usually never given as a number. Okay. It's a number of compoundings per year. Now, if it says it's compounded monthly, there's 12 months in a year, so n would be 12. If it's compounded annually, there's only 1 year per year, so n would be 1. If it's compounded quarterly, there's 4 quarters in a year, so n would be 4. And semi-annually, that's every half year, so that's twice a year. Okay? So, Purple Grove offers 4.45% interest compounded continuously. If 1,040 is deposited now, find balance in 9 years. So do. It says it's compounded continuously, so the appropriate formula is the continuous compounding formula. Okay? Now, before I start plugging things in, I try to identify what the variables are, what the variable values are, because sometimes it's not as simple as it seems. So 1,040 is what we're starting with. That's our principal. We're looking for what the balance is going to be, an accumulated value in 9 years. Rate, either move the decimal point over 2 places or just divide that by 100, is 0.0445, and t is 9 years. So A equals 1,040 times e to the 0.400, e to the 0.0445 times 9th power. Okay? Every calculator handles this differently. So what I would recommend you do is multiply this out. Okay? So leave the e, 0.0445 times 9 is 0.4005. Okay. Now, on my calculator, which is a Casio, you will see, and you will typically see an LN button. On my calculator, it's right there. Some calculators, it may look like a capital I, but it's actually LN. Okay, right above that ln, you will see e to a power. Okay, now I can't get this thing to focus. Okay, but above you should be able to find e to a power if you hit shift or second. So, for me, I would just type in 1040 times shift or second, depending on what your calculator says, ln. So again, 1040 times shift or second ln. Okay? This is what it looks like on the calculator that I'm using. Okay? And in the nearest set, that's 2 decimal places, 1552, sorry, 0.27. Okay? Now for this one, it's still continuous. A equals PE to the RTth power, where A equals, P equals, R equals, T equals. Well, rate is still what it was before. T is 9. Now that 1600 is what we're hoping to have in 9 years. That is an accumulated value. We don't know what we're depositing, what we're starting with. As I said, determine what your values are before you start plugging things in. So I want to know when 1600 will equal e to the p times e to the 0.0445 times 9th power. Okay, that's my unknown. That is what I'm solving for. So what I'm going to do is, since that's my unknown, I'm going to switch the side and move it over here. Okay, so I have p. I am going to go ahead and simplify the exponent. I'm going to pretend that I don't know what the answer to this is. So 0.4005 times 9, sorry, 0.0445 times 9 gives me 0.4005 equals 1600. Now, my goal is to undo, I got p times this e to something. I'm going to do the multiplication by dividing. And yes, that is the arithmetic division symbol, and that's what I'm going to use. So p equals 1600 divided by e to the 0.4005 power. Okay, so I'll do similar to what I did here, except instead of timesing, I'm going to divide. So 1600 division, shift or second, ln, 0.4005. This is what it looks like on my calculator. Okay, if I can get it to show. Again, I'm sorry the lighting isn't very good in here. Okay, not for this. I have to darken it because I want the board to be very visibly clear. Okay? Maybe this other calculator will be a little clearer. Yeah, that looks better. Okay, hit enter or equal. Okay, so the nearest cent, that's going to be $1,071.98. The problem also said it wants the nearest dollar. So the nearest dollar, that is $1,072. Unless given reason to do otherwise, unless given reason to do otherwise, assume nearest cent. Unless given reason to assume otherwise. Okay, so here's something for calculus students, all right? At what rate will the balance be changing in 9 years? If 1,040 is deposited, create a model as a function of t. At what rate would balance be changing in 9 years? We'll need a derivative to do that. So first we're going to create the model, okay? Remember, it's continuously compounded interest, okay, where A equals, P equals, R equals, T equals. So A is varies. We're starting with 1,040, 0.0445, and T is varies. So A equals A equals 1,040 e to the 0.0445 teeth power. Okay, so we will use this to find the model, okay? Do. We are looking for dA dt at t equals 9, okay? Recall that d dx of e to the kx is k e to the kx. Okay, that's a differentiation rule, okay? An important one. You should memorize it. So for instance, e to the 1.4x would become 1.4 e to the 1.4x. Okay, that's a review. Okay? All right, so to do this, first, dA dt will equal the 1,040 parenthesis, and then we will follow this rule, but we'll base it on t. Okay? So, basically, whatever the constant is, will go to the front. And the exponent doesn't change. Okay? .28 e to the 0.0445 teeth power. Okay? So that's the derivative. Second, t equals 9. So that'll be 46.28 e to the 0.0445 times 9th power. Clean that up. Okay, 0.0445 times 9, 0.4005. All right, so 46.28 or 46.28 times shift ln 0.4005, and I get $69.08 per year. Okay, it's growing at $69.08 per year. Okay, when we get to that point.